So we had some issues where we didn't have enough magnets in our wheel, so the velocity update rate was too low, making it hard for us to control, so we added twice the amount of magnets, and that helped. Because it takes time for it to pull the cable, we got an amount of delay. However, we made it so that we have a shorter arm and we start at a closer to lock position so that we have faster response. This first graph shows data from our test where we locked up our rear wheel using our electronic brakes. The red line is our front wheel velocity and our rear wheel is the blue line, and you can see that it falls down to 0 and our slip value goes to 100% since the wheel is locked up. And the brake position is at max near 100%. The time taken to go from 16 miles per hour to about 5 miles per hour was about 3 seconds. This test was with the rider trying to modulate their brakes to simulate ABS without locking up the rear wheel. However, you can see that there's going to be some delay before the rider lets go of the brake after the wheel locks up. It took around 3.5 seconds for us to slow down from 16 miles per hour to 5 miles per hour. So this final graph shows our anti-lock braking system in action. The black line is the output from our PID controller, and it will hover around 90% so that we maintain a slip of around 9%. And our wheel slip never goes to 100%, so then we have a faster stopping time. It takes about 3 seconds to go from 16 miles per hour to 5 miles per hour, which is comparable to us locking up our rear wheel, but since the rear wheel isn't locked up, the rider can steer normally and is much safer. This is our locking mechanism. This 3D printed mount will be bonded to our frame, and this aluminum rocker arm will be attached to our swing arms with a tie rod, and when one wheel goes up and the other goes down, the rocker arm will rotate, allowing us to tilt. And if we want to lock it, we can press our brake lever and it'll lock our tilt lock system. And if we want to stay upright for a long time, when we're going straight or slow, or when we're parking, we can hold the lever for 3 seconds, and then if we let go, it'll stay locked until we re-engage the lever, and it'll let go.